Thanks.
This is actually a very cool space.
Yes.
And I actually want to mention something, that the setup and everything else is way above standard. The mic, like, can you see the mic here?
Ooh, oh.
The projector, everything is like super cool. So I'm very happy to be here. Sometimes it's not, like this, so you have to scramble around with projectors or cables and things like that. So, what I want to do tonight is to tell you as much as possible about Amazon Web Services. But my understanding is that not the technical level here is let's say it's various. So there are very technical people and less technical people. I usually try to strike in the middle. I want to just disappoint everybody. But let's try to do this. I will try to follow my initial presentation. It's mostly about DynamoDB, and then there are a few other things related to AWS. But since a few of you don't know anything or pretty much anything about AWS, I will also add a few introductory notes here and there. But I don't want to make the technical guys fall asleep, so I will stay as technical as possible, okay? And feel free to ask any question at any time. That's actually the part that I like the most. I would preferably even take out the slides and just do a Q&A. Then let's use this as an excuse to then have a long Q&A together. Okay? Good? Nice. So, we start straight in with a couple of concepts, a couple of services that we have. So, AWS, Amazon Web Services, offers a huge variety of services. It's more than 30 now. Among them, there is one in particular that you should know about. It's called Amazon EC2. It's essentially virtual service on demand. And another service that you've probably heard of, which maybe you don't know well enough, it's called the DynamoDB. So DynamoDB is a NoSQL database. And just to give you some context, about 10 years ago, NoSQL wasn't even a common word. And there were two papers, one from Google, one from Amazon, one on Bigtable and one on Dynamo. And those two white papers essentially laid the ground for what became the NoSQL movement. So now, today, sometimes I refer to those things are NoSQL and the old relational databases as ESSQL. And NoSQL is a big family of things. DynamoDB in particular is a key value data store. It scales automatically. We manage it for you. So you essentially create things in Dynamo, query the database, and you don't worry about setting up machines or adding or subtracting machines or storage when you want to scale. But instead, you decide how much performance you want, and you pay accordingly. So it's a very different model than the usual NoSQL database, where you take the database engine and you install it across usually multiple machines altogether, and you have to manage that. And then there's another tool that we won't cover tonight, that we will need too much time. The tool is called EMR. This is something you should be aware of. So if you are interested in DynamoDB, after tonight, try to learn about EMR as well. EMR stands for Elastic MapReduce, and it's a managed Hadoop service. So instead of launching Hadoop, which is a Java framework for data-intensive application, instead of launching it and managing it by yourself, you can have Amazon run it for you. And there are a lot of cool things about EMR and how it integrates with DynamoDB, which I'm not going to cover tonight, but just to let you know. And another important thing, since a lot of you are developers or have a developer background, is how you interact with Amazon Web Services. We have multiple ways for that. Essentially, we have APIs for every service, and then on top of those APIs, we can provide additional layers. For example, a management console, a visual tool, or SDKs. About those few things, it's also important to mention that the management console allows you for like a secure connection, gives you multi-factor authentication if you want to, but it doesn't support every API available for Amazon Web Services. For example, if you want to do auto-scaling, so a feature that allows you to auto-scale the EC2 machines that you run, you cannot currently do it through the management console. You have to use APIs, like command line interface or other APIs through other meanings. If you want to use an SDK instead, it's available for many languages, PHP, Ruby, .NET, etc. And it's a combination of AWS libraries and material and packages, plus some community contributed content as well. And then you can use the command line interface, like plain old direct access to Amazon Web Services through essentially Java commands. And of course, it gives you secure authentication, so you can authenticate with your certificates and then do secure API calls to AWS. So this is a screenshot of the management console. This is the web page for the SDKs, this one in particular for Java. We also recently announced, I think it was this morning or yesterday morning, the new SDK for Node.js. This is a screenshot of the blog post. And also the tools for Windows PowerShell. If you are a Windows person, you know that now everything is essentially moving towards PowerShell as a way to develop things and do stuff on Windows machines. So now we also have a toolkit for AWS that uses PowerShell. And this is a toolkit for Eclipse. This is the command line interface. You can see here highlighted some of the commands you can send. And this is a quick image that shows you how you can connect to DynamoDB using the Boto library, which is a community-driven effort to essentially allow you to do those API calls through a very simple, very easy-to-use library in Python. So for example, you can import Boto and then create a connection with those parameters. The AWS secret access key, it's a previous variable that I created. And then you can connect through here. About EC2, a few important things. When you launch an EC2 machine, so a virtual server, you have full control of that machine. You are root if it's a Linux machine, or you are admin if it's a Windows machine, so you can do pretty much anything you do on a physical machine. You can also create your own disk image. So you can launch a machine and then customize it, and then create a disk image of that machine, which we call AMI, and then you can use that as essentially a fingerprint or a base to launch additional machines. We provide, of course, different levels of security. I'm actually not going to touch on those things. Maybe you have questions later. And you can run any type of service, any type of software on top of EC2, including Yes SQL databases. If you want to run Yes SQL databases or relational databases, but you don't need to manage them, you can use Amazon RDS, which is a managed service. So let's talk about DynamoDB now. And again, remember, if you have questions or if this is not interesting, raise your hand, let me know. Something like, this is too simple, this is too complex, or what is Amazon EC2 again? Anything you want, okay? Feel free to ask any question. So, yes, one question here.
So for DynamoDB, do you have iOS and Android SDKs or APIs?
So those are, yes, they support DynamoDB as well. So the mobile SDKs, they have libraries for the most common services, including DynamoDB. Some of the services are not currently available for those SDKs.
Sure.
But if you have a service that is not available, there are workarounds. Typically, there is either a community patch or a simple how-to or something like that that allows you to run that particular service with a workaround somehow. And always remember that the mobile SDKs are meant to be an easy way to develop for mobile devices, but you can always revert back to essentially a more low-level approach if, of course, you know how to do that. So essentially, we try to make all services available for every SDK, but we cannot do it all at once every time there is like a new service, for example. So DynamoDB, as I was telling you before, is a NoSQL database. This means that instead of having a schema that defines the database, just to give you an idea, a schema is something like primary key, ID, and then age, integer, first name, var, 80, so 80 characters, etc. Instead of having those things, you just tell us what is the primary key you want. And that's all you need to tell us. And then, of course, there are two types of primary keys. We're going to see this in a minute. One is essentially just a hash, so a single value, and one is a hash plus range. The point about the hash, let me tell you something very technical now. Imagine you have multiple machines to run your database, your DynamoDB database. We ask you what is the primary key, and if the primary key, for example, is the ID or a social security number or something like that, there's let's say, a nice distribution of values across the entire spectrum, which means with a hash function, we can evenly distribute across multiple machines in such a way that no individual machine will be essentially overloaded with requests while the others are almost idle. But if you pick something that is not evenly distributed, then the resulting function is a poor hashing function, which results in poor performance. And when I'm going to tell you about the CloudWatch features for DynamoDB, I will tell you why this is important.
So
yes, question.
You auto shard based on that?
Yes, we do that, but you are responsible for picking a key that is essentially distributed well. For example, a typical example is using an ID, which is just a number, from 0 to, I don't know, billions of numbers. That is something evenly distributed if you create them randomly. But if you use, for example, the HTTP code that returns from a page, you will have a lot of 200s, a lot of 404, and that's not evenly distributed because you will have tons of them and very few of the others. So it's a poor distribution. And that means that we cannot distribute across multiple machines in a proper way, so the performance essentially will be impaired. And actually, this is one of the key features, I will call it a feature actually, not a limitation of Dynamo. We'll tell you more about it in a minute. In essence, Dynamo was designed to be incredibly fast. And to do that, we limit what you can do on Dynamo in such a way that you have to design your code so that we can scale it seamlessly from like a very simple, very basic performance level, like a few reads and writes per second, to hundreds of thousands of reads and writes per second without any change in the code. So that's why you will see some limitations, some specifics here and there, across this presentation here. Those are some of the keywords to define how DynamoDB is designed. So auto storage scaling, it means that we automatically scale the storage used to store your database. We use SSD drives only, so it's very fast. It's redundant, so there's always at least 2 copies of the same piece of data across different SSD devices, different physical devices. And we take care of replicating those. For example, if you need a high level of performance for, let's say, a gigabyte of data, we're going to replicate that amount of data across tens or hundreds of SSD drives. And we take care of that automatically. You don't even know how it's done in the back end. You just know that you need that performance level. Let's say you need 10,000 reads per second. We will give you that performance level. And then we also allow you to specify those IOPS, but those are specific for a table. So if you have multiple tables, you can specify different performance levels. And then we have this built-in redundancy. So as I said, every time you upload to Dynamo, we'll see this later, there is some redundancy that makes the data you upload there very resilient to failure. We also give you the option of strong consistency or eventual consistency. Of course, there is a trade-off in performance. I will tell you more about it. We offer atomic counters. I will tell you more about it. And the writes are only to disk, not to memory. This is an important feature, again, because every time you write something to Dynamo and you receive a response that is essentially, yes, I wrote that piece of data into Dynamo, you know that it's not in memory, you know it's on a disk. So if there is a machine failure, so that particular machine or those particular machines that were managing your DynamoDB, if they fail for any reason, the storage is updated anyway. There's no memory loss, of course.
I assume that you can also set the number of copies when it's written?
No, you cannot.
Okay.
You only set the performance level, and that affects how many copies you have, but there is a
Okay.
minimum, and we will see how does it work, how it works. So this is a short video. This is the management console, and this is how you create a new table with items and attributes in DynamoDB. So you can specify the table name, for example, users. This is a string hash primary key. That's the only thing you need to specify, just the primary key, no schema. And here you specify how much performance you want, read capacity and write capacity. You can also set up notifications, for example, when the throughput level is getting close to the thresholds you have. And once you do this, the table is created, well, it's creating, and then after a very short amount of time, it will be available. And then you can refresh, and then it can be available. And then once it's available, you can add items to this table and specify attributes for those items. So a very important thing to understand in NoSQL databases, and particularly in key-value databases, key-value data stores, is that you have an item which has a primary key, an ID in this case, and it might have multiple attributes. So for example, here I'm creating a Simone as an ID, age 35, and favorite color, which is another string, which will be pink, for example. Yes?
Can Dynamo generate the IDs?
There is a way to automate that, but we don't generate that for you. So there are, for example, relational databases that allow you to just say, when you don't specify a primary key, it will generate one automatically for you. We don't do that. You have to essentially specify that. However, there are some libraries. I don't think it works for our libraries, but third-party libraries that allow you to not specify the primary key and only the attributes, and essentially will generate a random key, which is actually good in distribution. So there are essentially extra features for that. So this is a screenshot of the AWS Explorer in Eclipse. So it allows you to also essentially have a view of your tables. This is almost useless when you have huge data sets, but this is good when you are just playing out with Dynamo, just with a few items and a few attributes to see how they work. And of course, you can use this also to add items or change items. This is another example of how you can create a table with the Java API. So you can see here you're creating the schema in that part. Of course, those ones are not code. I just use them to divide the sections for you to read them better. Here you can specify the provision throughput you want. It's compulsory. You have to tell us how much read and write you want. And here, that's when you create a table with those schema and throughput that you specified above. So this is an example. Of course, this might be daunting for you. Like, this is very complicated. But of course, this is the low-level API. And when you want to do things with Dynamo, it's usually easier to use higher-level libraries, essentially. This is, for example, how you can create the same table with the Boto library in Python. As you can see, it's very simple. You define the schema there, and then you create a table here by specifying the throughput. And you can see that the syntax is much simpler and shorter, also because it's Python, but also because this is not a low-level API function, but it's using libraries. So, very important. When you delete a table like this is a permanent deletion. Of course, you can have backups somewhere, but when you do this, the table on DynamoDB is deleted. So my suggestion, also learning from experience, is to have different users with different permissions. And for example, you can have a read-only user, which is usually very useful to let your read-only applications access the database, or some of your users be able to see the content without being able to change anything. And you can manage those permissions with a service called IAM, which means Identity and Access Management. This is an example how you define those permissions with IAM. This is a read-only user. You can see that the user can use only those APIs. So it's just a read API, essentially, no write, and it allows only for those. And this is instead how you specify a user that can do anything. there's a star there after DynamoDB. So this is a user with full access. And this is a picture of the IAM console if you want to do it visually. This is a video of how to scale the throughput. So you already started a database, you want to change the throughput from 10 to 20, for example, and you want to disable the basic alarms. Then you save this, and then the throughput will be changed. And in the backend, we might add storage or add machines, depending on whatever we need to guarantee you that performance level. So now this part is more interesting because this is not just specific to Dynamo. Well, there are some things specific to Dynamo, but most of it is very important for any NoSQL user or most NoSQL engines. So you have attributes, items comprise one or more attributes, and tables comprise one or more items, or 0 or more. And this is an example just to give you an idea of how you build this. So this could be a table that we call products. And you have to specify what type of primary key you want, either hash or hash plus range. And then you can create items inside this table. So those could be 3 items. And those items should have, in this case, we specified ID as the primary key, should have an ID, which is compulsory, and potentially additional attributes, as many as you want. Yeah, and then the other 2 items as well, with their IDs and other attributes. This is a scalar data type, and this is a multi-valued data type. So, for example, in that case, the author is 3 different values. So we support scalar or multi-data types for the attributes. So the scalar is a number or a string or a binary, and the multi-value is a set of numbers or strings or binary. And the values in a set must be unique, but they are not ordered. So if you say Simone, Mark, and John, and you say Simone, John, and Mark, those are the same thing because there's no order there. So why do we give you those 2 things? Why did we create this function of either hash or hash plus range primary key? So as I was telling you before, the main key that we call just hash is hashed over the different partitions to optimize workload distribution. Hash plus range instead is like different because when you query, you can specify a range operation on the range part, and of course it helps you, for example, say, I have an order ID and I have a date. You can say I'm querying and I want to get the information about orders in the last 60 minutes. And that is something I can do when I have a range function in it. So again, you can build your table in such a way that then you can use it the way you want it and scale it essentially seamlessly. So this is an example of a table where you only have a hash, so just the ID. And this is a table where you have hash plus range. And so when you query, you can use a range as well. And this is how you create this in Ruby, for example. You can create a table there. You can put an item in the table, and then you can query with a specific time range. And of course, the point here is not to read every single line for you, but just to get a sense of how it works. There are 2 operations you can perform. One is called query, one is called scan. There is a very important difference here. And again, this is terminology that applies to NoSQL engines in general. So query is just a search using the primary key, which could be hash or composite, and supports a subset of comparison operators. It gives you up to 1 megabyte per query operation. So if you want to query gigabytes of data, you have to do this multiple times. The scan scans the entire table, which means when the table grows, scan gets slower and slower and slower. So essentially, scan is something that you use with a lot of caution, only when you know what you're doing. And there is a reason why. For example, this is from the forums. The query comparison has some limits. So, for example, there are some functions that are not available, and those limitations are built in such a way that the developer need to design its software for DynamoDB with a little bit more effort at the beginning. But the advantage is that then, for example, an operation like contains is very interesting because you want to use it. And then you say, why you don't have that operation available? Because if we give you this operation, your code would not scale seamlessly. But you will need to redesign your code. So we are trying to force developers somehow to develop in such a way that whatever they build, it can scale seamlessly up to the biggest levels. So when you write to DynamoDB, there is, for example, a common issue with concurrency systems, one of which is called the lost update, and that's how DynamoDB gives you a solution for that. So in Dynamo, put, update, and delete are always ACID, and the isolation is only at the item level. The other ones are always there. So in this example, this is time. I have a DynamoDB there. I have two clients, and I have an item there with ID and price. If both clients get the item, so they read it, get item is the operation to read it, and then both of them change the item to two different values. One is 12, one is 8, and then they try to write it back to the database. Of course, it happens that the first one changes it to 12, the second one overwrites and gets it back to 8, which means those two are now no longer the same. So there is a lost update issue. And of course, you can solve it very easily, as it happens in distributed systems. Same thing, both clients get the item, and after they change it, before being able to write, they essentially do a conditional write. And the conditional write essentially says, if the price is still the same there, yes, you can put the item back in Dynamo. In this case, the price has changed, so I won't allow you this operation. And so you can design your application to avoid the lost update issue. There is another feature called atomic counters, which is somehow the counterpart or conditional writes, because conditional writes are an idempotent operation. There is some overhead because every time you want to write back to Dynamo, you essentially do another read, and you check if the two values are the same or not. That's the if part. Instead, sometimes you just need to count something, and you don't care if it's you count something twice or you lose one of the counting. That's what the atomic counters are for. You can increment or decrement by 1, for example, and they allow multiple, even thousands or simultaneous requests, but of course it's not idempotent, so you can lose some of those updates. But this is good, for example, for, let's say, the number of hits on a website or things like that. Another important concept for NoSQL databases is consistent or eventually consistent reads. So a consistent read essentially consumes more read capacity that you have for your DynamoDB. For example, if you have a table and you have 10 reads and 10 writes per second, if your reads are consistent, then you will have half of them. And of course, the consistency is reached within a second after the last write. The eventually consistent read, essentially you can read immediately, but you can read either the old or new value. And there is a reason why we say after a write and between parentheses 2 copies. So let me explain how this works. You have a client in DynamoDB, and a client has an item and wants to put the item in DynamoDB. Once the client does this, we replicate across at least 2 devices before telling you, yes, your put item worked. And then we keep copying across additional devices. So there is never just one copy of your data there, which means your database is very durable, essentially. Even if there is the loss of one of those physical devices, your data is still there. And you can enable consistent reads by just setting up a flag, like this one, with a true value, for example. So we have a very simple set of APIs. For tables, we have those 5. For items, we have those. I think there are 2, those 2, and the query and scan APIs, and there are 2 more in the works. And there are features that we provide with something called CloudWatch. CloudWatch is a monitoring service, and CloudWatch can tell you all those things about your DynamoDB. In particular, throttled request is very important because it means that some of your requests have been throttled, and this is usually an indication of a bad distribution of your hash or primary key, or sometimes it's something else. So, simple example. I just recorded a simple example with Boto. You can download and install Boto from GitHub, of course. Actually, this video, you shouldn't see it. It's pretty simple. You can enter your AWS credentials here, and after you enter them and you import Boto, you can connect. You can create a connection string and connect to Boto, and then you can perform operations using the library. For example, in this case, I can list the regions and I can connect to a specific region. Those are the currently available regions for DynamoDB. In this case, I'm connecting to US East 1, and then I can list the tables in that region. Those are the tables I have, those 4 tables for now. And then we can use this schema, the one that you saw before. Oh, sorry, this is a different one, in which I have a hash key and a range key, so the forum name and a subject. And I want to create those items there, so the ID will be AWS forum, the range will be, the subject will be hello, so the range, and other attributes as well, and this one as well. It's a second item with those attributes. And then you can define those with this Boto library. This is the schema up there. You create a table here called messages using that schema. Then you create a table. And this one describes the table itself. This is not easy to read description, but it gives you all the attributes names, all those things that you specified there. And then you can enter those items and attributes. I think there's another piece of video. Yes. Here I can put an item into that table. So this is the item, and then table.new item. The hash key is AWS form, the range key is hello, and then I'm entering those item data there, and I can put it there. And I consumed 1 capacity unit. In this case, I'm writing, so I'm consuming write capacity. And then I can read the item, so I'm consuming a read unit. And then I can add another one using the management console visually, but I don't think you need to see this. It's pretty simple. And then you can say, okay, I can understand Boto, but what happens if I want to use something else? We have essentially a huge set of libraries or wrappers, mappers, for essentially pretty much everything else. So this is just a quick tip on Hive. Hive is a very useful tool if you want to move data to and from DynamoDB or query data in DynamoDB, but I'm not going to cover this today. Dynamo essentially, those are the costs you pay per write and read per second, and you pay for the storage. The storage is way more expensive than other types of storage because it runs on SSD drives. And yeah, those 2 things, you don't need them. Or there's a free tier in case you want to play with them. So customers essentially use Dynamo, for example, for those things. You have clients, you have a database there, and you can use S3 as a data store and DynamoDB, for example, for metadata. Okay, this is an important concept here. So this is from James Hamilton, VP and Distinguished Engineer at AWS. So this is why he thinks that DynamoDB changed the game in the NoSQL space. So essentially he says, what happens if one entire data center fails? With DynamoDB, when data is written, even if one entire data center goes down, your data still stays because we replicate across multiple data centers. And essentially, in its view, combining this type of redundancy with single-digit millisecond access to your data is a very rare feature to see achieved today. And those are some of the features of DynamoDB listed in this case. So conditional updates, we talked about it, libre partitioning, so you can have a table and you can tweak performance, and we would adjust the storage and compute capacity in the backend without without the need for you to do anything. Essentially, it's like you have this, like this stereo thing that you can move around to decide how much performance you want. So, a few quick things on NoSQL. NoSQL was actually conceived by this Italian guy named Carlo Strozzi in Italy back in '98, but then it became popular a few years later. And what's very important to understand in the NoSQL space is that there are different types of NoSQL engines. Some of them are the document store engines, like MongoDB, for example. The key value store, like Cassandra or Redis, and those are schemaless. There's no schema besides the primary key. There are the graph database, which is a very different concept. And then there are many other families. And of course, DynamoDB is part of the key value store. So most of the time people say, how do you compare DynamoDB with MongoDB? Well, it's not a fair comparison because they serve slightly different purposes, even if they are both considered NoSQL engines. And when you look at structured storage, typical of databases, there are essentially a few different approaches. One is feature first, so you need to serve specific features. And this is common in financial space, in human resources, CRM, and other things. And this space is dominated by relational databases. Then you have scale first. Twitter, for example, is a good example. Those systems where you need to scale massively, and it's usually a good combination between your relational database to keep relations and the key value store to be able to scale and provide a good performance level. Some of them are simple structured storage systems in which you need query, of course. And a good example is BerkeleyDB or SimpleDB, which is a service that we offer as well. And then you have the purpose optimized. In those cases, you have a specific purpose, a specific subset of needs and requirements, and sometimes they build services or data structures only for those specific types. VaultDB is a good example. And those two here are good for NoSQL engines, including DynamoDB if you want. Scaling, let's say, this part essentially, it's very difficult to scale relational databases. It's much simpler if you run a NoSQL database, and it's effortless if you do it on Dynamo because Dynamo does everything automatically. And in particular, you have synchronous replication, durability, etc. So scalability is important because this is a good example of how you can save money. Your IT needs are the blue line there, capacity and time. So there are typically multiple types of usage patterns in traditional IT, on and off, fast growth, typical of startups. You have the variable peaks or the unpredictable ones. Sorry, predictable or unpredictable? Yes, question here.
So basically, you want to use maybe like the NoSQL for like transactional kind of data.
For example,
things like
yes.
account properties and
Yes,
stuff like that you do in the
in most cases, in those cases there, a relational database would be still good enough because you usually don't need to scale a lot unless you are one of the few, like PayPal, for example, uses MySQL massively. But that's a kind of an exception. Most of the others would still be fine with relational databases. What's really interesting with NoSQL databases, including Dynamo, is that if you think you will need to scale, or sometimes you need to reduce the complexity of your environment, then a NoSQL solution might be a good solution for you. But sometimes you can easily use MySQL, PostgreSQL, and then just go with that. Well, it depends how much.
We have a product that involves a lot of messaging between users.
Yes.
And maybe the messaging part of it would be really good.
Yes. For example, we have a product for messaging called SQS, but so SQS has specific features. Sometimes people need different features. There is a product called the RabbitMQ, for example, that is a different type of messaging service and also does a few other things. And sometimes you can use Dynamo, not exactly for messaging, but to handle the key value part of a messaging system. That will be fine. So depending on what you want to build around it.
What would you use, like, if you don't need to keep the data at, like, if you're putting data in and within maybe anywhere from a few hours to a day,
You can still use
retrieved and then you're done with it.
You can still use Dynamo, and you can essentially delete the old data. If it's only for messaging, probably you need to use a messaging service, either SQS or a third-party solution, because you just need to use it. If it's for multiple things, you can easily essentially delete the data after you don't need it anymore. In fact, there's a very important concept in general in distributed architectures that is also easy to implement on AWS or cloud computing, which is to reduce your costs. You always have to consider how, like the temperature of your storage, like hot storage, warm, cold, cool and cold, for example. So storage that you need to access immediately, you want it in memory or fast drives. And then you can go down in the temperature scale and you can have cold storage, something that you need to archive, but in the case you need it, you can even wait a few hours before getting that data out. And for that, for example, we have a product called Amazon Glacier.
Right.
So in between, there are different levels. Amazon S3, EBS, and there are different costs associated with it. So if you know this, let's say where your data should be and how long should it be in that particular segment, then you can optimize your infrastructure. And that is true also for normal infrastructures. It's just easier in the cloud because you have essentially a very flexible system to do that. Okay? So you're the only one asking questions. Does it mean that everybody's following me or you're lost? Let's say, are you lost? Raise your hand. Okay, 1, 2, okay. Any particular aspect that you didn't follow? Like anything I can fill you with? Like any gap, anything I can...
Actually, I had a question.
Okay.
The difference between the primary key hash and what you were calling a table, and how does that relate versus like a schema in a relational database?
Yes, it's okay. So think of a table as something very similar to a table in a relational database.
Yes.
So a table is just a container, and you specify that within that table you will have items either with just a hash primary key or with hash plus range primary key.
So there's one of those hash things per table. Is that correct?
No, well, essentially, think of it as it's not a schema, because the schema is not, the primary key is everything else, but you can think of it as the base for a schema that then you don't have the schema afterwards. So, let's say, go back to the example. You have a table, you call it users.
Right.
And then you say, when you specify the table, that every item inside that table will have a primary key, which will be just a hash key. And then when you are inside the table and you create items, you can have ID 256, ID 1021,
right.
ID 7536. And every time you enter an item, you put an item, that item should have that primary key, otherwise you cannot order it, you cannot index it. The reason why you need to specify the primary key when you define the table is because then we're going to create storage and allocate resources to then store your items. And every item would have the primary key and eventually additional attributes like ID and a value, name, Simone, age 35, whatever, how many, as many items as you want. Sorry, as many attributes as you want. So table contains a number of items, and every item could be one or more attributes, of which you need to have the primary key. Right. That's how it works.
And for best performance, the primary key needs to be randomized.
Well, not necessarily randomized. Essentially, there should be
Or evenly
evenly distributed.
evenly
Exactly.
distributed.
Exactly. So make sure that if you have a primary key that is, let's say, heavily distributed in part of the range and weakly distributed in the rest of the range, you know that when you scale, you will have a performance issue, and it will see, for example, throttling as a message from your CloudWatch, because essentially the database will tell you, hey, I'm having issues here. But that's something very easy to do. Actually, most of the time you do it, even if you don't know it. You pick something that is evenly distributed, even if you don't know it. But you can do the other thing on purpose. You can say, let me do it in the wrong way. Yes?
We need to take like the 5-minute pizza.
Oh, pizza is here. Of course, I want to take it away from
We'll be
pizza.
back and really get into this.
Okay. Nice. Thanks.
Okay, great.
Okay. So ready to get back?
Yeah.
Yes? Okay. It's actually always better after a pizza,
Yeah,
right?
right.
Everything looks better. Now you start loving DynamoDB. Oh, this is so beautiful,
Yes.
right? I know the feeling. So, this is a map of the global infrastructure. So we have multiple regions. One of them is red. That's a special region. We call it GovCloud. That's only for government agencies, US government agencies. All the others are, let's say, available to the general public, and each one of them has multiple availability zones. And essentially, those are isolated, physically isolated data centers. And then we have edge locations, which are used for CloudFront and Route 53. There's actually more than 35 now. It's 38. So, I want to mention a few things before I end up with the slides, and then we just open for Q&A. So, Redshift is one of these services that we recently launched. This is a data warehouse service. It's not available to the public yet. If you're interested, you can go there, fill the form, and tell us why you're interested. And this is one example, though. This is why it's interesting. One example of how we are evolving the AWS platform. So we essentially look at areas where there is a need for innovation and where large-scale, high-volume, low-margin infrastructure can bring benefits. And usually we do this through customer feedback. So a lot of customers were asking about something like this. So we took this feedback and we created Amazon Redshift. So right now, if you want to do data warehousing, it's essentially still pretty much old-style IT. There's a huge initial investment needed. You cannot decide exactly how much storage or capacity you need, but you essentially have to buy capacity in big batches, which makes everything very expensive. And the cost per terabyte, that's usually the measure used in a data warehouse to express how much you're paying for your data warehouse service, it's quite high. So Redshift is essentially our way to say we want to try to disrupt this space as well. So the cost is essentially less than $1,000 per terabyte a year. That's the cost of the entire data warehousing solution. And what's interesting about Redshift is that we announced 2 new instance types, which will also be available for Redshift. Those have very strange names, like high storage extra large data warehouse node, or high storage 8 extra large, etc. Those ones essentially have a specific amount of memory or storage. And of course, you can pick one of those 2 instance types when you want to use Redshift. We also announced a service called AWS Data Pipeline, which is something that you can manage visually. You can essentially create data nodes like those, or activities like those. A data node could be, for example, an S3 bucket. S3 is our storage service. So this could be the origin of your data, and then you can run some algorithm through EMR, the Elastic MapReduce service, and put the output into another data node, and you can essentially decide when those things have to happen. You can schedule them, and this is essentially pipelines for your data. So most of the time when you need to manage those types of flows in your architecture, you usually need to implement whatever mechanism provides you with this. Now you can do it with the data pipeline. So that's how the service is for. Another service which you might not be aware of is called the Cloud Search. It's search in the cloud. So instead of implementing your own search with your own search engines, in the sense of software that you install in your servers, and those softwares, they index your data and then they provide you with the search functionality, you can do it with Cloud Search. Glacier,
Can you say more about that?
Yes. So it's actually a big topic. So most of the time, when people look at this and they don't know what search is about, they think, well, search, why? Why the reason for a service like this? So there are very specific customer types, let's say, and those people, they need to implement search either for external use or for any other internal use. And implementing search is very difficult. Essentially, think about that you need to build another Google or another search engine for your own storage, for your own data. And doing that is very hard, especially when you scale. If it's a small data set, there are open source tools, you install them, they work fine. Or when you start to scale, it's very difficult to build a search function that works well and scales well. So you can either do it by using EC2, installing whatever software you want to run, or multiple types of softwares together, or you can use it through Cloud Search, which of course works much better if your data is already on Amazon EC2. Otherwise, you would have latency between Cloud Search and your local data storage.
So are we
yes.
talking about text?
Well, yes, text in general is text search. There are some advanced functionalities, like, for example, specific char set types, specific languages. I remember I had a question from a guy from Russia. There's this company called SoundTracker, which is a very successful mobile app that runs everything on AWS. They need to implement search also for the Russian markets, and they were having issues with the locale, essentially, with the different char set. And so there is a function that allows you to implement different char sets. So text search also in different languages. Glacier, I've been asked about this a couple of times during the pizza break. So this is essentially cold storage. The tagline for me is 1 cent per gigabyte per month. That's how much you pay for Glacier. So this means that whenever you need to archive data, and just to be clear, archive is usually when you need to preserve data, but when you need it, you can wait a few hours before getting that data back to you. So those cases where you have, let's say, regulation or just backups that you want to do, and you don't care if that data is not immediately available. So the fact that we don't need to give you that data immediately, but we can wait a few hours, allows us some engineering that reduces costs. That's why we can offer it for 1 cent per gigabyte per month. And this is an interesting point, very interesting. I don't know if you can see this clearly, but this is a YouTube video that tells you how to use Amazon S3 and Amazon Glacier together. When you have an Amazon S3 bucket, there is a tab which allows you to specify essentially the life cycle rules for that bucket. And you can use it just to say whatever is in this bucket expires after 30 days. But you can also use it to enable, you probably can see this expiration here. You can also use it to transition to Glacier automatically. Remember the hot, warm, cool, and cold storage, let's say spectrum? Once you are in the cool part, you are on Amazon S3, you can automatically transition to cold, and based on whatever preference you have, you can say, once some data is 2 months old, I want to move it to Glacier. And instead of paying a few cents per gigabyte on Amazon S3, I will pay 1 cent per gigabyte on Glacier. And you can, of course, eventually retrieve it if you need to. So this is a way to automate that data lifecycle I was telling you about. This is very important. Support is, in my view, one of the most underestimated features of Amazon Web Services. And to be clear, there is free support, the basic one, and paid support, everything else. But if you look at this one here, the second column, the developer support is essentially $50 a month. The other two are slightly different. They cost, the cost per month is the greatest between either 100 or 10% of your bill, and in the other case, I think it's 420% of your bill. So those ones can be relatively expensive, but if you are using AWS for production uses, those might be actually a very good value proposition for you. But it's very important, in my opinion, to consider this as an entry point into support. And you might say, why should I pay $50 more per month? Because you get support on anything you want to do on AWS. Particularly at the beginning, it's very important because you can ask questions. You can, let's say, there's a machine that doesn't work properly, you don't know what to do. This could be the best way, not to just do troubleshooting, but also to try to essentially understand better how to use AWS. And especially when you are implementing something for the first time, your first few projects, it's very important to have this with you. One thing that I particularly like about the support, the two options on the right, is what is called Trusted Advisor. Actually, let me give you a quick overview of how it works. So this is my account, and this is my support center. This is Trusted Advisor here. I can also have health checks here, and those are my recent cases that have been resolved by support. Trusted Advisor here, if I click here, I should be still connected. There are essentially three sections which are equally important. The first section tries to help you with reducing your AWS bill. So this one here, for example. This one tells you 3 out of 3 EC2 instances are potentially underutilized. You can have annual savings of up to $3,000 by essentially moving to reserved instances. Then there is an elastic load balancer that is idle. Actually 0 out of 1, so this is okay. So when it's green, it means you're fine. When you see this, it means there is some optimization you can do, and here as well. So those are to let you save money. Those ones are to improve your security. For example, you don't have multi-factor authentication enabled for your account. You better do it. Or your security groups have some open ports that are potentially dangerous. Those other things are fine. And then, the third one, equally important, fault tolerance checks. Most of your snapshots, actually all of my snapshots, this is a test account, so don't worry about that. I usually do those things properly. But this is a test account. All of my snapshots, they don't have, all of my volumes, they don't have recent snapshots. It means if those volumes fail and data is lost, I essentially cannot retrieve recent backups of those volumes. An elastic load balancer is not configured properly. It means that there is an even number of machines across multiple of our busy zones. Those things are fine. So as you can see, there are many checks. And this thing, just the Trusted Advisor itself, usually helps you in saving money, improving the security, and the fault tolerance of your infrastructure. And this is an amazing value that you can get if you subscribe to support. Okay, this is the end of the deck. So it's 10 to 9. What time should we stop? 9 or what do you
9
think?
to 9:30, depending on the...
Okay, 9 to 9:30. Okay, so let's say the next 15-20 minutes we do some Q&A. I probably have a hard stop at 9:15 because I have a call at 9:30 with Singapore.
Okay.
So let's say 9:15 I need to leave the building, but I can stay until 9:15. So feel free to ask questions now on anything related to AWS.
I have a question on Glacier.
Sure.
So is Amazon doing anything where you can ship drives to Amazon? And have
Yes, it's called the import-export. You can physically ship disk drives to Amazon, and right now, those disk drives are stored in Amazon S3, and then you can move them to Glacier. Right now, there is no functionality that allows you to store them directly to Glacier, but that's something we're going to offer in the future. Because as you can guess, it's a common request.
Be a rough time to be Iron Mountain.
Sorry?
Be a rough time to be Iron Mountain.
SDN, software-defined networking.
Yes.
What's the status of
We don't share much about it. So there will be something related to how we manage our networks internally.
Because sometimes I like to make my own network so I can protect some of my assets from everyone else.
Okay, so let's say there's something that, let's say the most important part related to networking, which is not necessarily software-defined network in this case. It's a product called VPC, which means Virtual Private Cloud. So think of VPC as you have let's say our cloud, you can call it public cloud if you want, that's a common term. And then you can launch machines and use storage, etc. And then you can configure security groups and other things. And that's how you would use it normally. But with VPC, you can define a specific area, let's say, of our cloud and make it private in the sense that you can define much more within that perimeter, including, for example, who can access that perimeter. By default, you can only access it through a VPN connection, VPN tunnel, from your own premises usually. You can enable a gateway to the internet if you want those machines to access the internet as well. And you can have multiple VPCs together, configured in such a way that you can essentially build the network topology that you want. And you can also have two things inside VPC. One is called ENI, Elastic Network Interfaces. So those are virtual network interfaces that you can move around and attach to an EC2 machine. So it gives you the flexibility of moving those interfaces when you want to. The other thing is the fact that you can map those machines into local IP addresses in your local network. So for example, if I have my own infrastructure here and Amazon Web Services is there, I need one more server, but I want a server that looks like a local one. I can launch a server there, map it with a 10.0.0 something address here. All of the other machines will think this is a local machine because I'm using 10.0.0x to access that machine. But instead, when I try to access that IP, my router would route that request through a VPN tunnel to VPC, and then that machine is essentially virtually located in my data center now. The only thing to consider is latency, which is not local, but is through the network. And you can optimize that in a few ways. For example, you can use Direct Connect if you want to have a direct connection to AWS. Or you can optimize connections through data compression and other things, or Riverbed and Asperasoft services, etc. So essentially, VPC is a way for us to move the networking part of a cloud environment to the next level in terms of enhanced security and much more control on individual components and the network topology that you want. But this has essentially nothing to do with how we manage the network plane and if we use or not use like software-defined networking or other things. That part is something that we don't share. We don't share a lot of details about how we manage those things. We share whatever is needed for customers to know what type of security we offer. But then most of everything else, we try to keep it quite secret because we think it's our competitive advantage.
So are there like training courses on this?
There is something like that. So let me just open.
'Cause I could see a time where, you have a network administrator who would be a cloud network administrator.
Oh yeah, of course. So this is the first page you want to look at. It's aws.amazon.com/AWS-training. Actually, I think that just training should work as well. And here you can find some courses. Most of them are physical classrooms, and we have it in multiple places. I think we also have them in LA. Big data, CSOP, AWS 101, etc. And then we are slowly building a much bigger, much broader platform for material and documentation and training, which is coming up in the next few months.
Okay.
So it's not ideal, it's not perfect, but it's coming up. Yes.
Using VPC as you described earlier, how much better is the security going to be than doing the traditional?
Let's say, I wouldn't say it's necessarily better. I would say that VPC gives you features, extra features, that enhance your security. And also, that's most important, they give you controls, fine-grained controls on aspects of your security. So you can build a much better security for your cloud, especially when you have regulations that you have to adhere to.
Like PCI compliance?
PCI, yeah, exactly, or similar ones, especially in those cases.
So doing it the traditional way, it wouldn't be secure enough. You would have to do it this way to.
No, let's say the traditional way is secure enough. The thing is, there are some things that are very difficult to build, some like configurations that are very difficult to build using just the traditional EC2 machines. That's why we built VPC. And we built it and then we enhanced it with additional features. Now it's a very interesting product that gives you all the tools you need to build even those complex environments that, for example, are needed for specific regulations or maybe for enterprise needs, like high-level enterprise needs. So it's not that one is less secure, one is more secure. It's more about additional features that you have.
And one example is VPC lets you define outbound rules, firewall rules. So normal EC2, you can define who's allowed to access your instance at a certain port, but that instance can talk to anybody, anywhere, going outbound.
Exactly.
So VPC, you can define a subnet, you define subnet rules and firewall rules that control everything around.
And you can do that also on EC2, but it will require you a lot of effort because you will need to build essentially the tools that provide that functionality. So for example, EC2, the security groups are essentially firewalls for built-in traffic. And that's the basic functionality Eric was talking about. With VPC, you can say, this is my VPC, and this is how my machines can go out, if they can go out.
Right.
I can even say, no machine can go out. It's only through my VPN tunnel, from my office to VPC and vice versa, no outbound traffic at all.
Right.
You can set up a gateway, you can set up NAT, you can set up other things, and also different VPCs, and decide which one can talk to which other.
Okay.
So it's more control, essentially, on how you configure your security environment.
I have an idea of how to use MapReduce with systems like MongoDB, but would you be using MapReduce also with Dynamo?
I'm not sure I understood the question.
Well, they're sort of two parallel systems, but I don't know if they work in conjunction with each other or if Dynamo has its own MapReduce data function.
Oh, no, okay. So, for example, if you want to, let's say, back up your DynamoDB,
Okay.
you can do it using EMR, Elastic MapReduce. You can also do it by calling APIs and building your own little backup mechanism, but it's not efficient, of course. So there is some integration between DynamoDB and EMR because there are specific functionalities of NoSQL engines, and in particular of DynamoDB, that work very well in conjunction with Hadoop or related products. So Hive, for example, is a good example. Hive integrates very well with DynamoDB to query, to move data in and out, etc. And Mongo, I don't know why you mentioned Mongo though. Was it, you said Mongo as well in the beginning?
Yeah, it's just, I know that you can, it's suggested that if you're doing specific extensive calculations on the data, it's you're supposed to export it to MapReduce as opposed to doing it within Mongo. I understand that.
I don't completely agree. I think it depends on what you are trying to do.
Okay.
So essentially, let me try. Let me see if I can answer this question. So you have a NoSQL engine, and you crunch data. You put data in, you query data, and that's it. Most of what you can do with EMR is related to backing up that data to S3 through EMR. Most of what you can do with Hive is usually related to querying using SQL-like syntax against DynamoDB. Mongo is not exactly part of the equation, or Cassandra or any other NoSQL database, because the way Dynamo is built, you don't manage the database engine by yourself. You just have this thing that works by itself. You query, you can either put item in or read items, and that's it, pretty much. I mean, that's very basic. And we do all the rest, all the background, all the backend stuff for you. Instead, if you run MongoDB, then you decide how you want to do backups, how you want to manage things, depending on your specific need. So there's a lot. I mean, it's a big topic. We could even talk about it for a few hours. And I'm not even an expert. There are people that could talk for days about that. So that's the general idea. I don't know if I answered the question more or less.
Thank you.
Okay.
Security and privacy question. So my company's got, let's say, running now on Amazon Web Services, and someone puts a discovery request on me, and did it go through you guys typically, or how does it work?
That's probably something that will require legal expertise to answer. In general, that's something I'm not good at, so I don't know the topic very well. So usually there are some details about safe harbor, those kind of things on our website. I would suggest to look at that, because I tried multiple times to answer the question. What happens is that I have other questions in response to that, and then I'm stuck. Okay, that's way too much, way more than I know. So I usually just try to refer to terms and agreements, the safe harbor statement that we have, and then anything that works for AWS is essentially the same that works for any remote hosting service, more or less. So usually lawyers know enough about this subject matter to give you an answer. I'm not a lawyer, so I would just prefer to point you to the right...
Well, thank goodness, because if you were, we wouldn't trust you, right?
Suppose I had data that was like recording tracks from a recording session.
You mean
something.
audio?
Yeah.
Okay.
And I wanted to put it in cold storage, because I got tons of it, most of which probably will never be accessed again. But would I need to encrypt that before I put it into?
It's up to you. We always suggest to encrypt, not because you don't need to trust us, just because it's best practice.
Okay.
So if you talk to any serious sysadmin, they will tell you that they encrypt anytime they can, unless there is a very compelling reason not to encrypt on the first place. That's just standard, very good security practice for any system.
So what if I have disk volumes that the entire volume is encrypted?
Well, you can use encrypted file system as a base, or when you archive, you can even run an encryption algorithm on top of those files using, for example, Amazon EC2, or you can even do it through EMR if you want. Depends how complex or how complete your encryption should be. Depends on essentially what use case you have.
Well, I guess if the whole volume is encrypted, like with TrueCrypt, let's say, it would be a little bit hard for you guys to load it, because it's going to look like, it's going to look like it's not really a file, but it's going to look like a 2 terabyte block, more or less, right?
Well, I've seen in most cases where there was a need like this, some people would use EFS, encrypted file system. Some others would there's a function in S3 called server-side encryption,
Uh-huh.
So when you send a file to S3, we call it an object. When you send it, it's through SSL. So the file itself is not encrypted, but the transmission of the file is encrypted. But as soon as it arrives to Amazon S3, then we encrypt it for you. So that's called server-side encryption, essentially. And you can read details there. Yeah.
Are you talking just S3 or also on EBS volumes for encryption? The question. Because if you're talking EBS volumes, those are block-based, block store devices. So TrueCrypt or Crypt setup, Luke stuff, that stuff is fine to put on top of EBS.
Okay.
Because it encrypts each block separately.
Right.
And the block is written through to EBS, and that stores it. Amazon doesn't get to see the raw data then.
Because there's no files per se.
Well, the file system is on top of the block device,
Right. Okay.
which is so EBS volume, block device, Crypt setup, or TrueCrypt, file system, files.
Okay, cool.
So ABS is very much like a hard disk drive. It's a block device. But actually, TrueCrypt can use multiple different types of encryption algorithms.
Yeah.
You can essentially get the same effect just by running those algorithms on individual files and then storing the encrypted files on a file system,
Right.
if you want to.
It does block encryption too, though, right? Block device encryption.
TrueCrypt, you mean?
I thought it did,
Sorry?
yeah. It does TrueCrypt.
I think it does, but I don't think you can do it on EBS because you will need, let me think.
I use Crypt setup on top of EBS or Instant Store.
Yeah, it's the
I
best.
think
the
TrueCrypt
best
is
approach.
similar, but
Yeah.
I haven't used it.
Any,
Crypt setup.
Crypt setup,
Crypt setup.
LUKS, there's the different levels of things working with each other to make encryption on a block device.
it's actually pretty straightforward.
Yeah, once you figure out the right commands, there are very few.
And for example, one of our solutions architects always recommends to run that type of setup with EBS, unless you have a reason why you don't want to use that. And not because he's on AWS, that's his approach in life. Like encrypt unless otherwise. Which is actually a good security approach.
Yeah.
Because most of the time, security is always an interesting aspect of any IT system. And essentially, encryption, the way we know encryption, it's like a recent modern invention somehow. The tools that we have now. The encryption we had 100 years ago is nothing compared to what we have now. So now the functionalities you have are really interesting. So why not use them? That's one of my colleagues' point, which I almost agree with.
Well, I think it'd be great if you guys sponsored like a AWS-based hackathon type thing.
We did a hackathon, but it was not, I don't think it was the type of hackathon that you were thinking about.
Because there's a lot of really cool products built on top of AWS that put kind of like a user interface over, and combine a few services.
Okay.
And cost isn't just an incremental difference. It can be transformational in terms of, like I started using a backup service that's built on AWS a few years ago. That's just an interface. I paid directly AWS for the storage space.
What service is that?
Jungle Disk.
Oh yeah, of course.
And the difference in cost versus using something like Carbonite or Movier, that I just started backing up entire drive. Like I don't care anymore. It's like I don't care if it's 50 gigs or 80 gigs because it's so inexpensive.
Yes.
You can afford
Same
to
with
do that.
like Dropbox or
Yeah.
any others. Dropbox, for example, runs on us as well.
Uh-huh.
So yeah, I agree. And actually, I think that Glacier is now bringing a lot.
Yeah, that's going to be.
Yeah. It's
Right.
very recent. We
I
launched
have
it like 2
boxes
months
of
ago.
drives myself that I would love to just put up there.
Yeah,
and I don't
no.
have to worry about it.
Actually, I have several friends that moved all their photo albums
Yeah.
to Glacier a
Uh-huh.
few days after it came out. They,
Uh-huh.
developers,
Yeah.
people that can code in Java and do it by themselves.
Yeah.
Yeah.
So if you're going to upload like 100 terabytes or something to Glacier, so is that actually going to be redundant? So it's going to be
Yeah.
copied several.
So Glacier and Amazon S3, they share the same durability design. It's not guaranteed durability, but we designed for 11 nines of durability, which means 99.9999%. 11 nights,
Right.
which roughly, it equates to, in human terms, if you have like 1 million files, on average you lose one every 100,000 years. That's 11 nights of durability. So, but that's, to be clear, that's not an SLA we give you. So we design it to be that durable, but we don't give an SLA on that. So most of the time when people say, well, I need an SLA or I need a higher durability, just tell them, do it in 2 regions. So
Right.
it's way more durable than.
Now, are you paying for it twice, or it's just?
Well, if you do it in 2 regions, you essentially pay twice. But even in the case of Glacier, 1 cent a gigabyte, let's say you pay 2 cents, it's still
Yeah.
way below any other solution in the market.
2 cents.
Yeah.
How long would it take to get back your photo?
So essentially, the way Glacier works, and one of the reasons why we can draw prices down, is that we will start giving you back those files after a few hours, typically 4 to 5 hours. And then you pay only if you retrieve more than a certain percent of your total archive. Now, it's not easy to explain this model in a few words because there are different use cases you can have. In essence, the most important information is up to 5% a day of your archive, your individual archive, you can pretty much get it for free. Anything above that, you pay based on tiers, based on other things. So, let's say, I give you the simple explanation. If you have an entire infrastructure and you back it up all on Amazon Glacier, and it's 100 gigabytes, and all of a sudden you lose the entire infrastructure, you want to retrieve all of it from Glacier, then you will pay an interesting amount of money. Still very reasonable, but you will pay money. Instead, if you back up to Glacier and you retrieve every once in a while small pieces of it, you essentially pay only for the storage, the 1 cent or gigabyte per month. That's a dumber and approximate explanation of our pricing model. But of course, you can see the details on the page if you want to see exactly how it works. There was a question there? No, okay. You're just...
Well, actually, with Glacier, are they using, there's low RPM drives that the hard drive vendors are releasing that are called Glacier as well. Is that related to any hardware developments, or is it just
okay. No, I didn't know about
positioning of the
this.
service? Yeah.
So we essentially don't share how we do it. We still think it's one of our competitive advantage.
Sure.
I can tell you that there is a lot of smart engineering behind Glacier, because being able to offer it at 1 cent a gigabyte, it means we're either crazy or we engineered very well.
Floppy disks.
Very nice.
It takes 6 hours to find where they put the disk on the shelf and load it in.
Redundant array of floppy disks.
I actually saw something like that. a few years ago.
Yeah, that's fine. I had a question about the pipeline product. Does that take away any of the throughput that you have reserved for Dynamo, or is that a separate
No,
predefined?
the pipeline essentially is just a way for you to design those pipelines and say, this is the source data, the data node. I want to perform this operation through EMR and store the output there and schedule this, for example, every day or every week. That's pretty much how it works. So it's a data pipeline. It's a flow of data around your different pieces that you can automate and
So an
manage.
SDK or a GUI or something to help you manipulate data.
Exactly, pretty much. That's it. So, and right now, remember, every time we launch a new service, we launch it with a rather simple set of functionalities at the beginning, and then based on customer feedback, we iterate and keep adding functionalities. So what is available now, it's something, but then in the future, it will be much more complex and much richer as a service. So you will see additional features coming up in the coming months. I think I need to...
Hey, I want to thank everybody for coming out, and especially thanks, Simone, for coming down
Thanks.
from
Pleasure.
Amazon. Dan Data and our hosts at Cross Campus. If you didn't check in on your way out on meetup.com and rate the meeting. So